Welcome to today's lesson on calculating current, voltage, and resistance in series circuits. Today, we will be putting into practice the concepts we learned in our last lesson about series circuits. Today, we will work through several practice questions to calculate the current, voltage, and resistance in a series circuit. In our previous lesson, we learned about the difference between series and parallel circuits. We also learned that in a series circuit, the current is the same through every component because there's only one continuous path for the electrons to flow through. We compared this to people in a single file line walking down a hallway. We then learned that in a series circuit, voltage is divided among the components. We imagine this to be like people receiving the same number of tickets or energy from the battery at the beginning, but then having to give some of their tickets to each component on the way. So by the time they return to the battery, they have not got any tickets left. Finally, we learned that the total resistance in a series circuit is the sum of the resistances of all the components, and that the idea of equivalent resistance can be used to help us understand this. Today, we will put these concepts into practice by working through some calculation problems. Suppose we have a series circuit with a 4-ohm resistor and a 6-ohm resistor connected to a 12-volt battery. We want to calculate the potential difference and current through each resistor. First, identify what's given in the question. We know that the resistance of resistor 1 is 4 ohms, the resistance of resistor 2 is 6 ohms, and the total voltage supplied by the battery is 12 volts. Next, identify what we want to find out. We want to find out the potential difference, V, across each resistor and the current I flowing through each resistor. Now, identify the relevant equations. We know that current is equal to the potential difference divided by the resistance. We also know that equivalent resistance equals the sum of resistances. We can't directly calculate potential difference or current yet, but we can calculate the equivalent resistance, which equals 4 ohms plus 6 ohms, totaling 10 ohms. Remember, this equivalent resistance conceptually replaces all resistors with one resistor. The current in this new circuit will be the same as the current in our original circuit. So the current in the circuit is equal to total voltage divided by equivalent resistance. This is 12 volts divided by 10 ohms, which gives 1.2 amps. Since current is the same throughout a series circuit, the current through each resistor is 1.2 amps. Now, we can calculate the potential difference across each resistor. For resistor 1, voltage is current times resistance. This is 1.2 amps multiplied by 4 ohms, giving us 4.8 volts. For resistor 2, voltage is current times resistance. This is 1.2 amps multiplied by 6 ohms, giving us 7.2 volts. Presenting the final answers, we have found that the current through resistor 1 is 1.2 amps, the current through resistor 2 is 1.2 amps, the voltage through resistor 1 is 4.8 volts, and the voltage through resistor 2 is 7.2 volts. By understanding this problem, we can see how current, voltage, and resistance behave in a series circuit and how they relate to one another. This understanding is crucial for analyzing and troubleshooting series circuits in practical applications. Let's step it up a notch in this next example. Suppose we have a series circuit with two resistors, a 4-ohm resistor and another resistor with an unknown resistance. The circuit is connected to a 20-volt battery. The voltage across the 4-ohm resistor is measured to be 8 volts. We want to calculate the resistance of the second resistor. Firstly, identify what's given. The resistance of resistor 1 is 4 ohms, the voltage across resistor 1 is 8 volts, and the total voltage from the battery is 20 volts. Next, identify what we need to find, which is the resistance of resistor 2. Then we calculate the voltage across resistor 2. The total voltage in the circuit is 20 volts. We know that the total voltage is equal to the voltage across resistor 1 plus the voltage across resistor 2. So 20 volts equals 8 volts plus voltage across resistor 2. Therefore, voltage across resistor 2 equals 20 volts minus 8 volts, giving us 12 volts. Next, we use Ohm's law, voltage equals current multiplied by resistance, to find the current through the circuit. First, we find the current using the voltage across resistor 1. Current is equal to voltage divided by resistance. Substituting in our values, this gives us 8 volts divided by 4 ohms, which equals 2 amps. We then can use Ohm's law again to find the resistance of resistor 2. The resistance of resistor 2 equals the voltage across resistor 2 divided by the current. Since this is a series circuit, the current through resistor 2 is the same as the current through resistor 1. Therefore, the resistance of resistor 2 equals 12 volts divided by 2 amps, giving us 6 ohms as a final answer. Now consider another circuit with 2 resistors connected in series. One of the resistors is 15 ohms, and the current through the circuit is 1.5 amps. The total voltage supplied is 45 volts. We want to determine the resistance of the second resistor. Let's identify what's given in the question. We know that the resistance of resistor 1 is 15 ohms. The current through the circuit is equal to the current through resistor 1, equal to the current through resistor 2, which is 1.5 amps. We also know that the total voltage is 45 volts. Next, identify what we want to find. We want the resistance of the unknown resistor, resistor 2. We can then calculate the total resistance using Ohm's law. Total resistance equals total voltage divided by current. This is 45 volts divided by 1.5 amps, giving us 30 ohms. Now we can find the resistance of the second resistor. Total resistance equals the resistance of resistor 1 plus resistance of resistor 2. So 30 ohms equals 15 ohms plus resistance of resistor 2. Solving for the resistance of resistor 2, we get resistance of resistor 2 equals 30 ohms minus 15 ohms, which equals 15 ohms. Therefore, the resistance of the second resistor is 15 ohms. Moving on to another example, suppose we have a series circuit with a 5 ohm resistor and a 10 ohm resistor connected to a 15 volt battery. We want to calculate the potential difference and current through each resistor. First, identify what's given to us. We know that the resistance of resistor 1 is 5 ohms, the resistance of resistor 2 is 10 ohms, and the total voltage supplied by the battery is 15 volts. Next, identify what we want to find out. We want to know the potential difference, V, across each resistor and the current I flowing through each resistor. Now identify the relevant equations, which are current equals voltage over resistance, and equivalent resistance equals the sum of resistances. We calculate the equivalent resistance, so equivalent resistance equals 5 ohms plus 10 ohms, equaling 15 ohms. Next, calculate the current in the circuit. Current in the circuit, I, equals total voltage over equivalent resistance, which gives 15 volts divided by 15 ohms equal to 1 amp. Since current is the same throughout a series circuit, the current through each resistor is 1 amp. Now we calculate the potential difference across each resistor. For resistor 1, 1 amp multiplied by 5 ohms equals 5 volts. For resistor 2, 1 amp multiplied by 10 ohms gives 10 volts. Therefore, our final answers are that the current through resistor 1 equals 1 amp, the current through resistor 2 equals 1 amp. The voltage through resistor 1 equals 5 volts, and the voltage through resistor 2 equals 10 volts. Let's make it a bit more complex for our last example. Suppose we have a series circuit with 3 resistors of 2 ohms, 3 ohms, and 5 ohms connected to a 20 volt battery. We want to find the potential difference and current through each resistor. First, identify what's given. The resistance of resistor 1 is 2 ohms, resistance of resistor 2 is 3 ohms, and resistance of resistor 3 is 5 ohms. Total voltage supplied by the battery is 20 volts. Next, identify what we want to find out. This is the potential difference across each resistor and the current flowing through each resistor. Now, identify the relevant equations. These are current equals voltage divided by resistance, and equivalent resistance equals the sum of resistances. We then calculate the equivalent resistance. Equivalent resistance, 2 ohms plus 3 ohms plus 5 ohms equal to 10 ohms. Next, calculate the current in the circuit. The current in the circuit equals total voltage divided by equivalent resistance, which is 20 volts over 10 ohms. So we get a current of 2 amps. Since current is the same throughout a series circuit, the current through each resistor is 2 amps. Now calculate the potential difference across each resistor. For resistor 1, V equals IR, which equals 2 amps multiplied by 2 ohms, giving us 4 volts. For resistor 2, V equals IR, which equals 2 amps multiplied by 3 ohms, giving us 6 volts. For resistor 3, V equals IR, which equals 2 amps multiplied by 5 ohms, giving us 10 volts. This gives us the following final answers. Current through resistors 1, 2, and 3 is 2 amps. Voltage through resistor 1 is 4 volts. Voltage through resistor 2 is 6 volts, and the voltage through resistor 3 is 10 volts. That was our last question. Good work today. Continue revising and practicing these calculations.